This is a quick explanation of the inverter design for the course of electrical drives. To start, it is to mention that three different in-feeding voltages are used. These are the DC link of 50 volt and only input to the PCB. And then with two DC-DC converters, we can get a VCC that is 15 volts and 3.3 that is labeled as micro because of the microcontroller. So all of the signals are filtered with electrolytic bypass capacitors. So we're going from the microcontroller to the MOSFETs. In order to control this inverter, we need three pulse width modulation signals. These are three, A, B, and C, each one for each phase. And it is important to select pins that are associated with the timer of the micro. So, as we can see, because of we are using A4 sheets, we use 5 different schematics. This doesn't matter because they all refer to the same circuit. So, we use 3 schematics for each phase. We're going to check the first one. They are all the same. The only thing that changed is the different phase. We have this PWM that goes through an optocoupler. This is very important because we have to operate with 2 isolated grounds, and this integrated circuit will allow us to do that. On the left side, we have the low ground, referred to the lower power elements and the high power one. So once this step is done, the output can go to the driver, and this driver will control both the up and the down MOSFETs. These MOSFETs are protected with opposite center diodes that can ensure that we can have voltage here that could be too high. Also, it is to mention that we have the 15 volts, but we can get 2 outputs. These outputs are filtered with both an electrolytic capacitor and a ceramic capacitor. We use 2 of them because we want to have a signal as smooth as possible. As output of this leg of the inverter, we have, of course, our current. This current could go directly to the motor that we want to control, but as we want to control it, we have to measure this current. For this purpose, we use Hall sensors of the HO8 and P series. This Hall sensor allows us to measure between -8 and 8 amperes, and that will work for this inverter that wants to operate with a value between the 2 amperes. On the right side, we have the input coming from the MOSFETs, and this output can now go directly to the motor. On the left side, we have as in-feeding the 3.3 volts for this integrated circuit. We use, of course, the low power ground, and as output, we have a voltage signal that corresponds to the measurement of the current. This voltage will go as input to an ADC of the microcontroller, and because of that, we want to conditionate it so that we can use the whole range of the ADC. This purpose, we use an op-amp that is fed with the 15 volts. We have as input this measurement of the Hall sensor, and this output will not yet go to the micro. Firstly, it has to be filtered here with a low pass filter. So once we have the lower signals, now it can go into the micro. Once again, we have to make sure that each of these measurements is assigned to a pin with of the ADC of the meter. We have some other extra elements, as can be three buttons that will help us to select the operation mode of this inverter. These push buttons are connected to a pull-down resistor, and this output is filtered as well with a low-pass filter. This way we can ensure correct debouncing and avoid doing it on the software. These button signals are processed in a digital way, and then we can control two LEDs in order to indicate which operation mode is being held. Also, we have as output four PWM signals that are as well filtered with a low pass filter, and this output will help us to make some extra measurements. And almost on the end of this design, we have as well two reference in order to make our control system. These are analog signals that oscillate between 3.3 volts and 0 volts and are just set with a potentiometer. That goes through a low pass filter. And finally, in order to communicate this printed circuit board with the external world, or better said, connected, we have connectors. We have four different connectors for each PWM signal as output for measurements. We have the input of the single DC link of 50 volts. And of course, we have the three phases of each current that will help us to control our motor.